Good morning, children. So today we are discussing the first topic in electricity, charge. Can you say what is a charge? So here the definition is there. All of you please write this definition. Charge is the inherent property of matter that feels force of attraction or not out or repulsion due to excess or deficiency of electrons. All the children please note this definition. Charge is the inherent property of the matter that feels force of attraction or repulsion due to excess or deficiency of electrons. Anyone who has written can read? Anyone please read it?
Charge is the inherent property of matter that feels force of attraction, out repulsion due to excess or deficiency of electrons.
I said to change one word. No, it's not out. It is or. Or force of attraction or repulsion. Deficiency means
lack of electrons.
Very good. Very good. Either having less number or excess number makes that particular matter charge. And that charge with another charge, it may be attracted or repelled. So every matter has that property. That's why we are calling this one as inherent property. Inherent property. So everything around us, even the mic you are holding and the pen we are holding, the book, every matter has a charge. But why we feel it is having charge means matter is generally neutral. Means how many positive charges are there, that many negative charges will be there. If this charges change or by shifting, by doing something, then what happens? No, the electrons will transform from one body to another body. Now, can you say one method that we have learned last year, that how the electrons will go from one body to another body?
Rubbing.
That's it. Good. Very good. Friction. So when we rub the body against each other, then what happens? Electrons will shift from one body to another body. Whichever lost the electrons, that body will become positive charge. That's what here you can see, that due to electron deficiency. Whichever the body gets the electrons, as it is having excess number of electrons, that body will have negative charge. So only two different types of charges are there. Can you say what are those?
Positive and negative
Positive
charge.
charge and negative charge.
And this charge is denoted by the letter Q. So please note down that thing. Charge is denoted by the letter Q. As we don't have any problem, you can use the small q, capital Q. Both the letters are applicable here. But tradition is small q. So what is the symbol we used to represent to the
Q.
Okay, now we know the units. Children, first of all, how the mass will be represented? How do you say? Will you say mass is equals to 10 rupees, 1000 rupees? How do you say?
Grams.
Grams or
Kgs.
kgs?
Kgs.
What is this gram or kg? We are saying we are call it as units.
Weight.
Units. Very good.
SI unit.
Yes, not SI units, simply units I am saying. Time is measured in which units?
Seconds.
Seconds, minutes,
Seconds, minutes, hours,
Good. Length?
Meters.
meter,
Centimeters.
meter,
centimeters.
kilometer.
Very good. So whatever this extra word we are keeping behind the number, beside the number, we call it as a unit. By seeing the unit, you can identify what is that physical quantity is. Now, whenever we write the charge, suppose I said 10. What should I write beside that 10?
Q.
Q.
Un,
Q is the symbol of
A
charge.
unit.
What is
C.
that unit?
C.
Yes.
Its
You are
unit.
right. What does the C stands for?
Columbus.
Columbus.
Columbus,
Columbus. Coulombs.
Columns.
Coulombs. Okay, what is the unit of charge?
Columns. Columns.
columns,
Coulombs. Okay. Now all of you write that thing. The SI unit of charge is coulombs. Generally, the charge will be in microcoulombs or millicoulombs or nanocoulombs. Children, can you say that if it is microcoulomb, you know how to represent it? Micro means 10 power minus 6. Nano means 10 power minus 9. Milli means 10 power minus 3. Please note it down. Milli, 10 power minus 3. Micro, 10 power minus 6. Nano, 10 power minus 9. Most of the time, the charge is measured in microcoulombs or millicoulombs. Okay, once again, what is this charge value? Already I said that every fundamental particle has some charge in it. What is the fundamental particle is responsible for the charge? Electron. Depends upon the electron only, either it is getting positive charge or negative charge. This electron has that charge. How much charge that electron is having?
1.6 power minus 9.
19 coulombs. 1.6 into 10 power minus 19 coulombs. Here you can see the charge of one electron is equals to 1.6 into 10 power minus 19 coulombs. This is the charge of an electron. Means now all of you write this question. How many electrons will make 1 coulomb of charge? How many electrons will make 1 coulomb of charge? I hope so that you understood my question. 1 electron is 10 power minus 19 coulombs. Means for 1 coulomb, how many electrons are required? It's a very simple one. All of you write this one. Number of electrons.
6 into 10.
Yes, Rohita, say Nana.
Sir, 1.6 into 10 power minus 95.
90, that is one electron charge, Nana. But I want how many electrons required for 1 coulomb charge?
1 by 1.67 into 10 to the power minus 19.
That's good. That's good. Please note it down. Number of electrons is equals to 1 by 1.6 into 10 power minus 19. It's approximately equals to 6 into 10 power 18 electrons. Okay, children. Now you got the answer now. How many electrons will make 1 coulomb of charge?
6
1
into
by
10 to the power.
10 power 18.
Electrons. Very good. Okay, how a body will get charge? By rubbing. We already have seen there. You can see this example. You see the picture when the glass rod is rubbed with silk cloth, then automatically glass rod loses electrons. That's why the glass rod becomes positive charge. So my question is, a body is getting charged. How?
By lose or gaining electrons.
That's it. Very good. Now it means any body charge will be equal to multiples of and means number of electrons that has lost into charge or not. In multiples of number of electrons, no. Suppose it lost 10 electrons. It means it is 10 electrons charge. Isn't it?
Yes, sir.
Every body will have the charge always multiples of the number of electrons it has lost or gained. So please note it down, this second statement here. Charge is, not are, charge is always quantized. Charge is always quantized. That Q is equals to number of electrons that has N into E there, right? First of all, Ne. Q is equals to Ne. What does this N stands for? What does this N stands for?
Number of
Electrons that has lost or
Gain.
gained.
good. Now, Nana, please write this question once. A body has lost 100 electrons on rubbing. A body has lost 100 electrons on rubbing. What charge does it contain and how much? What charge does it contain and how much?
It contains positive charge.
Positive charge.
Very good. Why? Because
It is losing electrons.
that's it. Very good, Nana. If a body loses the electrons, that body will get the positive charge.
Positive charge.
How much that value is? N is 100. Ne, I said no. E value is 1.6 into 10 power minus 19. So the charge on that object is equals to Ne.
1
Yes. 1.6
1.6
into
into 10 power 17.
minus 17. Okay. So, whatever the things we learned about the charge is a simple basic contents. So everybody will get the charge by losing or by gaining the electron. Now my question is, can I make this charge to move? Yes,
Yes.
we have to connect a wire. Through the wire, the charge will flow like water flows in the pipe. Charge can flow. Do you remember, Nanda? In social, while studying ocean currents, I think teacher has explained what is meant by current. What is meant by current? Current means movement. Wind currents means moving of the air. Now, here, what is moving? Electric charge is moving. That's why what do we call this one as? Electric current. Means movement of electric charge. But most of the time we are using the current regarding with electric current only. That's why the electric current word is fixed to the electricity. Current means movement. So once again, what is electric current? It is a flow
Of electric energy.
of electric charge. Now that the study of this electric current and related terms, we call it as electricity. How this electric current converts from one form to another form, how it flows, what is it required, what happens. These are all things we learn. That entire study we will call it as electricity. Okay, children. So today we have entered into our chapter, electricity chapter. First of all, we learned about a charge. Can you define what is a charge? We have written the definition.
Charge
Ojasvi, can you
is
read
the
the
inherent property of matter that feels force of attraction or repulsion due to excess or deficiency or lack of deficiency.
Very good.
Electrons.
Let we give opportunity to others. Any Vaibhav, can you read it?
Yes, sir.
Read, Nana.
Charge is the inherent property of matter that feels force of attraction or repulsion due to excess or deficiency of electrons.
Very good. Chaitanya Verma, can you read it? Left. Chaitanya Verma. Okay, I think it's not possible for you. Aditya Sharan, can you read? No response. Vivek? Okay, Pujita, you read, Nana?
Charge is inherent property of matter that feels force of attraction or repulsion due to excess or deficiency of electrons.
Children, if you observe, three parts are there in this definition. First part, charge is the inherent property of matter. Sai Pranita, can you explain what does that mean? Charge is the inherent property of matter means. Inherent means what? It is already having. You cannot define something else by someone has not given that one. It is having by its own. Inherent means having its own. So matter is the, charge is the inherent property of the matter. So it is, every matter has the charge. It did not come from anywhere. But how we can understand second point? Anyone can read?
That feels force of attraction or repulsion. Repulsion.
Very good. Nana, first point is what? Charge is the inherent property of matter that feels force of attraction or repulsion when? The third point?
Due to excess or deficiency of electrons.
Very good. Why that is feeling force of attraction or repulsion? Because
Presence
either
of
you have,
electrons.
excess of electrons or deficiency of electrons. Excess of electrons means that body became the negative charge. As deficiency of electrons means that body is having
Positively
positive charge.
charged.
Positive charge. As they acquire charge, they can attract or repel other charges. This property is already having, it's a matter's inherent characteristic property. So now, by adding these three, we can define the charge. Charge is the inherent property of the matter that makes its force of attraction or repulsion because of having the excess number of electrons or deficiency of electrons. I hope you got the definition of charge. Pranati, can you say the definition without saying to the book?
Charge is the inherent property of matter which charge is the inherent property of matter that feels the force of attraction or repulsion due to excess or deficiency of electrons.
Very good. Niharika, what about you, Nana? Can you say?
Charge is the inherent property of matter that feels the attraction or repulsion due to excess or deficiency of electrons.
Good. Nana, suppose you have pen in your hand now and notebook. Are they attracting each other?
No.
No.
Take a comb and comb your hair and bring the comb into the nearer pieces of paper. Then
It will
The comb will attract the pieces of paper.
why the comb is attracting the pieces of paper means
Because it is charged.
charged. Now you got it? How that body got charged? Because of
Rubbing with hair.
rubbing. Another word is friction. Okay. Now second, as we have seen, what is the key role? Which one is playing a key role for a body to get charged?
Electrons.
That's it. Very good, ma'am. Electrons are responsible for a body to get charged either by jumping into or getting from this electron. One electron will have how much of amount of charge?
1.6
Into
1.6 into 10 power minus 19 coulombs.
very good. The scientists have done the experiments and they calculated it. Every body can have any amount of charge or is it quantized?
Quantized.
Quantized.
What is its value? N into E.
N into E.
Number of electrons that has lost or gained into 1 electron charge value. Okay. And we also have seen how many electrons will constitute 1 coulomb of charge.
6 into 10 power 18 electrons.
That's it. Very good. Now, if this charge flows, we call it as
Current.
electric current.
Electric
The
current.
study of all these things, what happens when
Electricity.
the charge moves, electricity. So tomorrow onwards, we are going to see the technical words of this chapter, such as electricity, potential, potential difference, resistance. These three are very, very important. Current, potential difference, resistance. These three like ABC for the alphabets. So we will understand it and we will go through the chapter by doing some problems. And children, today's homework is all have to try to prepare the PPT as Niharika has done. And don't send it to me even in email audio also. You have to save in your pen drive or else Google Drive or somewhere. Like that, for every chapter, you have to prepare your own PPTs. So take some time. And second thing, I told you to complete speedy classification notes. No, I think you have done so. Did you?
Yes, sir.
Yes, sir.
If not, please try to complete as fast as possible. Good morning, Dhanush. Good afternoon, sorry. Okay, children, do you have any questions?
Sir,
Yes.
sir, you told us, sir, how many electrons will make 1 coulomb of charge. That once you can explain, sir.
1 electron charges how much?
1.67 into 10 whole power minus 19, sir.
10 power minus 19. So it is very, very less. It's like 0.0000001.6 something. So
Yes,
we
sir.
need some electrons to make 1 coulomb of charge. To get it, we have to reciprocal that value. 1 by 1.6 into 10 power minus 19. That is a mathematical calculation. When we do, we will get it 6 into 10 power 18. So how
Okay,
many
sir.
electrons will make 1 coulomb of charge means? 6 into
6 into 10
10 power
power minus 10 power 18.
18 electrons will make 1 coulomb charge. Okay.
Okay, sir. Thank you, sir.
Thank you very much. Thank you all the children for attending the class. Bye.
Thank you, sir.
Bye, Nana.
Thank you, sir.
Bye.
Thank you,
Bye,
sir.
sir.
Thank
Bye.
you, sir.
Bye. Thank you.
sir.
Thank you very much, Nana.
Thank you, sir.
Good
Thank
afternoon,
you.
sir.
Good afternoon. Good afternoon, all of you. Thank you, Vaibhav. Good afternoon. Bye.
Thank you,
sir.
Good afternoon, Rojeshri. Bye, Nana. Bye.
Thank you,
Nana.
sir. Right, sir.
Aditya Sharan, sit in uniform tomorrow onwards.
Okay, sir.
Bye.